transfer of heat is normally from a high temperature object to a lower temperature object. Heat transfer changes the internal of both systems using conduction, convection, and radiation. Heat will continue to move until both substances are the same temperature. The greater the difference in temperature between the substances, the faster the heat will transfer. The formula for heat transfer is mass times specific heat times temperature change. The equation for conduction is the thermal conductivity and the cross-sectional area multiplied by the difference of the higher temperature and the colder temperature multiplied by the time taken, all divided by the thickness of the material. Conduction is the transfer of heat as a result of the direct contact of rapidly moving atoms through a medium or from one medium to the other, without motion of the material. Materials that allow heat to travel through them in this way are called conductors. Metals are good conductors of heat, and non-metals such as plastic, clay, wood, and paper are poor conductors of heat. When one end of a rod is heated, the atoms vibrate faster and bump into the neighboring atoms, which causes them to vibrate. In this way, the atoms conduct heat from the hot end to the cool end of the rod. But during the process, the atoms themselves do not move from one end of the rod to the other.
Oh my god, it's so cold. Oh my god. If I get closer. I touched it!
Other examples of conduction are touching a stove and being burned, ice cream melting down your hand, and boiling water by thrusting a red-hot piece of iron into it. The equation for convection is the heat transfer coefficient and the cross-sectional area multiplied by the difference of the hotter temperature and the colder temperature. Convection is a transfer of heat by the physical movement of the heat medium itself. Convection occurs in liquids and gases, but not in solids. Convection occurs when a liquid or gas is in contact with a solid body at a different temperature and is always accompanied by the motion of the liquid or gas. Warm fluids rise, cool down, sink, and then are warmed again.
Leif, where are you? The pizza's not here. Can you get the pizza for me? There's no one here yet. The party starts in an hour.
I have the pizza. It was made in a convection oven.
Whoa. This looks really good.
Another example of convection is an old-fashioned radiator. The radiator warms the room by warming the air around it. Then the warm air transfers heat to the rest of the room through convection. Another example is hot air rising, cooling, and falling. As the air above the road warms up, it rises and is replaced by cooler air, forming a convection current. The equation for radiation is the Stefan-Boltzmann constant multiplied by the hot temperature to the fourth power, subtracted by the cold temperatures to the fourth power, multiplied by the cross-sectional area. Radiation is the transfer of heat in the form of waves through space. The sun cannot transfer heat to the earth by conduction because there is no physical contact with the earth, or convection because there is no liquid or gas between them. So the sun heats our earth by radiation, which does not require contact or the presence of any matter between them. Heat from the sun radiates through empty space to earth.
Would you like to go to the beach?
Yes!
Alright, let's go.
Don't forget to wear sunscreen to protect you from the radiation from the sun.
Man.
Other examples of radiation are heat from the sun warming your face and heat from a light bulb.